Welcome to the first in a series of online videos about Detect3D, which is the state-of-the-art fire and gas mapping software from Insight Numerics. I'm going to take you through a fire and gas mapping simulation using Detect3D, and we'll complete the entire project in about 10 minutes. So the first thing I need to do is to load in a CAD geometry. We support 6 different CAD formats. Here I'm just loading in a stereolithography STL file with about 40,000 triangles. You can see the model is now loaded in the 3D window, and you can pan, zoom and rotate around the model. The first thing I'm going to do is to add a flame detector, which can easily be done by right-clicking on flame detectors and selecting Add. To help position the flame detector, I'm going to use the Pick tool and select the far corner, then turn on Preview, which shows me the flame detector's field of view as I have it currently positioned. The field of view in red defines the limits of the flame detector's vision, so if there's a fire within the field of view, the detector will alarm. I want to rotate the flame detector so that it's pointing towards the process area, and then rotate it down. Once I'm happy with the placement, I can then add the flame detector to the project. You can now see it in the project tree. Many of you are now familiar with our raycasting engine, which calculates what the flame detector can actually see. Just like you and me, visual flame detectors can't see through things, and in Detect3D, the flame detector can't see past the obstructions in the CAD file. I can show you that here. We call this the obstructed field of view. Under the hood, the software casts out tens of thousands of rays, but the trick is that this is completed very quickly. If you were to try this in other commercial software packages, it would take hours, but here we've calculated it very accurately in less than half a second. Every fire and gas mapping project needs a fire zone, so I'm going to add one here. I right-click on Zones and select Add, and then using the Pick tool, I can select opposing corners of a cuboid that will define our fire zone. Once again, I can preview the fire zone to make sure it's right, and then add it to the project. The coverage statistics are available immediately to me, and they can be seen by clicking this table. As there's only one flame detector in this project, most of the fire zone has 0 coverage, but around 15% has coverage to one flame detector. I can visualize the coverage in the fire zone by using visibility isovolumes, which fill a volume at a set visibility. Here I'm adding one at 0 visibility, which effectively shows me the blind spots in the fire zone. Clearly most of the fire zone has 0 coverage, and the way to improve the layout is to add detectors. I'm going to look at this blind spot behind these 2 large tanks first, and place a detector there to improve visibility in this region. Again, I select Add Flame Detector, use the Pick tool, and Preview to check the position. This looks good, so I'll add it to the project, and notice that the new detector has been added and that the 0 visibility isovolume has been automatically updated. We can see immediately that the blind spot has been greatly reduced, so we're making progress, and I'm going to add some more flame detectors to the project. Okay, so let's put one at this manual location here. Looks good. I'll enter the coordinates for the second one. You can see the 0 visibility isovolume automatically updating, which is really nice because you can just go through the fire zone, adding flame detectors where you see blind spots, and come up with a very good layout very, very quickly. Just going to add one more flame detector at the corner here. Just rotate it around and have a quick preview. Yep. That looks good. Okay, so we can see the 0 visibility regions have been greatly reduced, but there are a couple of blind spots I want to have a look at. One here between these 2 buildings and one on the opposite side as well. So I'm going to add 2 more flame detectors to try and eliminate those regions. Add one at the corner here and rotate it around. You can see that blind spot's now been eliminated, so let's tackle the other one. Slightly translate it away from the corner. Let's see that one. Okay, the blind spot's gone from there as well. So we can see that the blind spots are now greatly reduced, and let's have a look at our statistics. We have about 10% zero visibility, nearly 90% one or more, and over 50% two or more. We can of course use ISO volumes at different visibility levels to have a look at these statistics in more detail. Here I'm adding an ISO volume at a visibility of 2 or more flame detectors, and that's going to appear in red. There we go. Finally, we can also use contours. I'm just going to turn off the visibility ISO volumes first, add a contour, and here I'm adding one at 2 meters above ground level. Just calculating that now, and we can see that appear. It's slightly transparent, so I'm just going to make it fully opaque so it's clearer. So you can see the colours much more clearly now. Each colour represents a different coverage level, and you can see what the colours mean on the bottom right. So that concludes our fire mapping project. We added 8 flame detectors and were able to reduce our zero visibility to around 10%, and it took us around 6 minutes of project time to do that. So let's move on to gas mapping. I'm first going to turn off the visibility of the fire mapping objects. We have 2 types of gas detectors that can be used in Detect 3D: point gas detectors and open path or line gas detectors. They both have something similar to a flame detector's field of view, but I call this a field of influence for gas detectors. The field of influence is based on the design gas cloud size and concentration, and the usual industry practice is to define a 5-meter spherical gas cloud at the LEL concentration. Here I'm going to add a point gas detector. I can add one here and see its field of influence by using the preview button. This red sphere shows the detector's field of influence. What it's showing is that if the center of our spherical gas cloud was in that red sphere, then it would set off the detector. Now, point gas detectors don't often come in ones, and you can add a regularly spaced array of detectors in Detect 3D all at once. So I'm going to do that here. I'm going to select 3 in the X direction and then 5 in the Y direction, update the preview, and now you can see all the detectors' fields of influence. I can add them to the project. Here I can see them. I'm going to add another array of gas detectors in a staggered manner on top of this array. I'm going to add the first one slightly offset here, and do another 3 and 5 array, preview that, and add that to the project. So now I have 30 point gas detectors in the project. Just like a fire mapping analysis, I can view statistics, add ISO volumes and contours to the gas mapping. Here are the coverage statistics for the gas mapping analysis, and note also that the fire mapping statistics are still in the project. Finally, I'm going to add 2 open path or line gas detectors. Their field of influence is slightly different, much more like a rounded cylinder. I can use the pick tool and add this first line gas detector to the project. I'm just going to add the second one as well as I'm here. Just preview it and add that one as well. If I zoom in on the open path gas detector, you can see the visualization of the transmitter and receiver and the beam between them, so you can tell whether there are any obstructions to the beam. Finally, let's have a quick look at coverage again. And the last thing I'm going to do is to add a contour in the gas mapping project at 3 meters above ground level. The colors again show coverage to 0, 1 and 2 gas detectors. So that concludes our fire and gas mapping project using Detect 3D. In the upcoming series, I'm going to look into some of the aspects of the software that I've not covered here, such as defining multiple fire zones, using different types of geometries and more complicated geometries, assigning different risk grades within a fire zone, testing reliability and maintenance, using fire targets, and outputting PDF reports of the detector positions. Thanks very much for listening. My name is Oliver Haynes from Insight Numerics, and you can find out more about Detect 3D by looking at www.insightnumerics.com or emailing info@insightnumerics.com.